got 32? Okay. So we have sine squared cosecant squared plus secant squared. I want to verify that that's secant squared. Okay? So when you're looking at this, excuse me, when you look at this one, we know that cosecant squared is the inverse of sine squared, e, right? So I'm going to just distribute these things in, but what I'm going to do is I'm going to distribute them into their inverses. Is that okay? Because now I get sine squared over sine squared plus sine squared over cosine squared. Everybody okay with that? Okay. Sine squared over sine squared is what? 1. Sine squared over cosine squared is? What is 1 plus tangent squared? Secant squared. And you're done. There's many ways to do that. How'd you do it?
I switched the
This is your one where when you distribute, you have to distribute the sine squared to both areas. So in essence, I kind of did the wrong way of doing it. I shortcut it a little too much. Your sine squared over sine squared always ends up being 0. All right. See how that works? All right. Okay. 33. So we want cosine squared minus sine squared to equal 1 minus 2 sine squared. Okay. Is cosine squared a perfect square?
Yes. Yes.
Is sine squared a perfect square?
Yes.
Okay. So does it help if we go like this? Does that help us to do anything?
I didn't do that.
No. Okay. Did you rewrite cosine squared in terms of sine squared?
Yeah.
Good. That's what you should do. Take a look at what happens here. We know that cosine squared is equal to 1 minus sine squared. Do you agree? So if I rewrite that as 1 minus sine squared, what do you get?
1 minus 2.
You're done.
Wow.
Yes, sir.
Oh, I see. Okay, so I solved it, but like I didn't. Like I did this.
Well, that's how. Oh, remember, what you have to do is make the left look like the right.
Yeah.
You're not trying to solve it through.
That's what it was. Like I solved it, I didn't.
Yeah, I see what you're saying. Did you enjoy those yesterday? Yeah. Of anybody, I figured you would have had a blast.
These were actually really good. Why would we?
Cosine minus sine, I want it to be 2 cosine. Minus 1, excuse me. What did you replace in that one? Replace the sine squared. So in this one, you'd have cosine squared minus, would be sine squared would be 1 minus cosine squared. And what you have to be careful here is to distribute the negative. And you get cosine minus 1 plus cosine, sorry, squared. And that's where you get your 2 cosine squareds. And it works. Okay. That's a very common trick to set up problems, because you can solve those things on intervals by using these trig identities to solve the equations. This is the kind of things that you can do some replacements with, because now if I wanted to set this equal to 0, I could solve it. Well, add 1 divided by 2, take the square root, so I get 1. what angles have a cosine value of plus or minus 1 over root 2? So, it's 60 degrees, so your pi over, oh yeah, sorry, it's 45, yeah, I'm thinking root 3s. So it'd be 45, so you're at plus or minus, so you have pi over 4 plus pi n. Pi over 2 n. So you use this plus minus, so it's all 4 quadrants.
Sounds good.
So this is the type of thing in section 14.4 that you can set equal to 0 and solve by using trig identities to get you your values. It's a hoot. Okay. Yes, sir.
Will there be ones that like you can't prove?
If they say that there's if they say verify, they give you an equals, it means it's gonna work. Okay. The simplify ones, you're gonna go to a certain spot and stop. Okay. Let's do this. Let's work on real quick these top two simplifies. So I want to start to get into more of the multi-step style to show you guys. You kind of started out all right, kind of keep continually adding a little bit to this. Yeah, if you want, it's fine. So let's see. We want to simplify sine times cosine divided by 1 minus sine squared. So let's see here. Numerator. If I multiply those two together, does it get me anything?
No.
Nope. But what is 1 minus sine squared?
Cosine.
Cosine squared. So my denominator becomes, I have sine cosine over cosine squared. What happens?
Get rid of the cosine.
Sine or cosine.
Which is
Tangent.
tangent. And that's a simplify. Okay? Same basic principle on the other one. See how it's just kind of, yes ma'am?
So for 19, if it were to be like sine plus cosine on the top, you could simplify the cosine.
Bless you. No, because you have, if it's, I think there's something like that with the fractions we'll get to in a little bit. I'll show you ones like that in a little bit, all right? 1 minus cosine squared over sine times cosine. Well, what's 1 minus cosine squared?
Sine squared.
So your numerator here,
The same.
you can get tangent. Now, what I'm hoping that you guys started to notice last night was that when you had squares with ones, minus 1 plus 1, you were looking at your Pythagorean identities. The other ones was a matter of, if you had secants, you were rewriting as cosines and so on and so forth. Hoping that you would pick up on that. They can get messy. You guys take a minute and do, let's see, do 21 and 22 real quick. Take a minute and do 21 and 22. We'll check it. When you walk through this first one, a lot of you tend to forget some rules of fractions, which happens. You have 1 over cosine times sine over 1 times sine over cosine. Now, thank you. In this group here, order of operations tells me to take care of multiplication first. So I'm going to combine those two fractions. I have 1 over cosine minus sine squared over cosine. Don't they have the same denominator? So you just put them together. When they have the same denominator, now you have 1 minus sine squared over cosine. What's 1 minus sine squared?
Cosine.
Cosine squared.
And it will be cosine.
Cosine squared over cosine becomes?
Cosine.
There you are. Hooray! Yippity-doo-dah, yippity-doo.
The super reader that you're to say this.
What's cotangent squared plus 1? Yes, ma'am.
Oh, I just have a question. How do you get the second part?
Well,
Like the original cosine minus sine squared.
What I did here is I rewrote all of this in terms of just sines and cosines.
Yeah, and then like, how did you change that to one, to sine squared? Can you just multiply it?
Yeah, because what happens when you're dealing with fractions, or even any problem, order of operations says to take care of multiplication before you take care of subtraction. So these two parts are being multiplied together, so I just rewrote it as sine squared over cosine. That's all I did. Okay. On the other one here, you have cosine squared times what? Cosecant squared. Cosecant squared is the inverse of what? So it's 1 over sine squared, so you have cosine squared, which is?
Tangent square.
I love the after part. I got this, I think.
Got that.
All right.
Okay, I had one minor slip up and I thought
Well, stop doing that.
cosine for
You're
like 2 seconds.
You're going to go
and I
to
corrected
trigonometry
myself.
jail.
Oh no.
Do not pass pi.
That would be sad.
Yeah.
I assume in trigonometry jail, instead of cakes, we multiplied files with pies. Oh, never.
This is 35. We'll walk you through 35.
Sometimes I'm okay, but other times.
Okay.
In number 35, you've got cotangent plus tangent, and you want it to equal cosecant times secant. So one of the dead giveaways of something to do, or an idea of something to do, is to notice that if your left side has addition and your right side has multiplication, in order to make that work, there had to have been some common denominator done. So let's rewrite cotangent and tangent in terms of sines and cosines. Since they're not squared, it's probably our best bet. Cotangent becomes cosine over sine plus sine over cosine. We all right on that?
Yep.
What would be the common denominator?
Sine.
Sine times cosine, you agree?
Yeah.
So if I make a common denominator of sine, cosine, fraction on the left needed a fraction on the right needs a
Oh, okay, so you multiply it by what the denominator you like did earlier in the year?
Yep. It's just like multiplying the polynomials.
Wait, how did we get the top part? Yeah, how did we get the cotangent?
Okay.
Like, I thought
Okay.
that was 1 over cosine.
Cotangent is 1 over tangent, but cotangent is also cosine over sine. Okay. Once again, in order to get a common denominator here, you're basically going to multiply the two denominators together. Think of it along the lines of this was 1/3 plus 1/4. If I multiply these two fractions together, I'd get 12. You agree? Now, 3 times what is 12?
4.
So the numerator needs a 4. 4 times what is 12?
3.
So the numerator needs to be multiplied by 3. What's 3 plus 4? So your answer would have been 7/12. Okay? Same exact idea when you have the word cosine or sine thrown in. If the denominator is going to be cosine times sine, this fraction has the sine, but what did it need to be multiplied by? Cosine. That's why I get cosine squared. This side needed the sine, so sine times sine is, what's cosine squared plus sine squared? 1.
Separate the denominator out.
Yep, and this is where, since it's 1 over sine cosine, you could split them apart and get cosecant and secant.
Yeah.
And that's how that works.
You can just leave it like that.
Yeah.
I don't want to simplify the other side.
Yeah, it-
What's 1%?
Always go from left to right. Don't work with the right side. Don't ever worry about the right side, okay? The right side is there just to tell you what it should look like when you're done. Let's try another one with the denominators. What's the next one? $36 has secant squared plus cosecant squared, and you want it to equal secant squared times cosecant squared. So once again, what we're going to do, we're going to take the left side and we're going to rewrite it in terms of sines and cosines. Secant squared is 1 over what? Cosine squared. So I have 1 over cosine squared plus 1 over sine squared. And then I do that thing. What's that thing? What is it going to be?
It's going to be sine squared plus cosine squared on top.
Very good. And what's sine squared plus cosine squared? Did everybody see how that worked? It's a very, what happened there, Caleb, is that in order to get the common denominator here, I'm just going to multiply these two together. That's where I got that. Okay. Fraction on the left had a cosine, needed the sine. Fraction on the right had a sine, needed a cosine. So I did 1 times sine squared, 1 times cosine squared, and that's where I got all that. So now what's sine squared plus cosine squared? 1. And aren't we done then? And that equals our secant squared, cosecant squared. The trick idea there is when you see going from addition to multiplication, you probably had to use common denominators. Oh, let's try. Mario? Yeah, it is. Work on 53. Excuse me. So I have sine over 1 plus cosine. It's not 1 plus cosine squared, or 1 minus cosine squared, so I can't use Pythagorean identity here. So in this case, when you have a 1 plus something or a 1 minus something, and your trig function isn't squared, what you want to do, usually, is multiply by your conjugate. What would your conjugate of 1 plus cosine be? Okay. So you wind up multiplying top and bottom by its conjugate. Because when you multiply by a conjugate, you're just multiplying by a factor of 1, and you're just changing the shape of it. You're changing the look of it. Okay? Your denominator, what happens now is that you wind up with a difference of squares, but it's just with trig function. So your difference of squares in this case becomes 1 minus cosine squared. Okay? Everybody on that? The numerator, I'm just going to multiply. I'm just going to say that it's sine times 1 minus cosine. I'm just going to leave it at that because I don't think distributing is going to help me do anything at all. All right. What is 1 minus cosine squared? Sine squared. So you wind up now sine over 1 minus cosine with sine squared. So what happens?
Sines cancel out.
How many of them, though? Just one of them. And now, aren't you left with 1 minus cosine all over sine? So what do you do when you have a single denominator, but 2 terms in the numerator? Split them apart. Good. You use the common denominator, but you're just writing it in long form. So you get 1 over sine minus cosine over sine. Therefore, it works to be
Cosecant minus cosine.
okay.
That was pretty cool.
it's kind of, I don't want to say that, I don't want to oversimplify the obvious that this is not easy, okay? There's a lot of weird things that can happen. And it's a matter of taking a chance and trying something, okay? If it doesn't work, just erase it and start over, okay? What's that?
I thought it was like a life lesson, but they were like, you just erase it and start over. I'm like, if I can do that.
No, you're the kid. Deep thoughts.
And math.
Two great things that go great together.
It was no verified.
I want to verify this one to be secant. I think I wrote that down right. Yeah. I want to verify that nasty looking mess. Make it equal to secant. Yeah, I think that's what it is.
Okay, after this, when you go back, I just don't see how you got, cosecant minus cotangent.
Oh, I just didn't finish that last step, Ben, because I had right here, I had 1 minus sine minus cosine over sine. That is cosecant minus cotangent.
What I did was,
I just didn't write it out.
I forgot to take out the square sign.
Oh, there you go. Yep. There you go. All right. Sorry about. I kind of quickly went ahead because I wanted to show another one of these real fast. What do you think you want to do first?
Conjugate.
Conjugate. Good. We'll do a conjugate to start. So we have secant minus tangent. You okay on that? Okay. My denominator becomes 1 minus sine squared. We okay with that? The numerator is just going to look nasty for right now, so we'll say it's secant minus tangent times 1 plus sine. Okay, I'm just leaving it like that for right now. We're going to come back to it. What can I do to the denominator to make it just a little bit easier for right off the bat? Make it cosine squared. So, is everybody okay with me doing this? Okay. Now, I need to work with this first parenthesis to try to simplify that out. I have secant minus tangent. Bless you. Secant minus tangent, if I just kind of do that off to the side here, is 1 over cosine minus sine over cosine. You guys okay with that?
Yeah.
So I wind up with this chunk is 1 minus sine over cosine. Okay. It's okay, we'll get there. We'll get there. On the other one, we have just 1 plus sine. Now I'm dividing by cosine squared. So if I start putting this stuff together, I've got terms now. We have, what do we have here? 1. This one's size. Probably should have foiled that instead of that.
Definitely.
Yeah, I wanted to do that.
I want to do that.
I foiled this. It is kind of lame, but watch what happens.
Wait, so yeah, scratch the top.
Yeah, but just like I said, so giant eraser is great to have for sometimes. If I do that, what's secant times, or sine times secant? It's tangent. So the middle terms here drop out. You get tangent minus tangent, so these go.
What?
Wait, I got lost.
Whoa, let's go back to these. Okay, hold on. Why do they? It equals what again?
Tangent.
Sine times secant is tangent.
Sine times secant is tangent because secant's 1 over cosine.
Sine
Ah.
I've seen.
Yes. I guess.
I just.
Wait.
I got
Let me
it.
write this. So it's secant minus 2 tan.
So secant minus tan sine.
Oh, and then plus and minus.
Right, so that's why the middle terms go out. So we have secant minus tangent sine. This is still all over cosine squared.
Yeah.
Okay? So now I still have that subtraction going on in the numerator, but can I rewrite that numerator in terms of all sines and cosines?
Yeah.
Okay. So now I have 1 over cosine minus sine over cosine.
Sine squared.
Can I write it as sine squared because it's sine over cosine times sine?
Yeah.
You also just went, yeah, whatever, I don't care. What I will do is write it out for you. just the utter sheer look of disgust was priceless.
It's 1 minus sine squared, which is cosine squared.
Okay? And he just went. So now the numerator is going to be 1 minus sine squared all over cosine because they have a common denominator. You okay on that?
Yeah.
That's just the numerator part.
And then so it's cosine's the answer though.
We're getting there. We're getting there.
Wait, but didn't we have cosine squared?
This is still all over cosine squared. So we're still working on the numerator. Okay? What's 1 minus sine squared?
Cosine squared.
It's cosine squared. So right now we have cosine squared divided by cosine divided by cosine squared.
Dang it. Forgot about that one.
Wait, can you just simplify that to just cosine?
We're getting there. We're getting there. We got like 3 circles to deal with.
It's not.
This is like even
Woo! I love this. This is great.
I thought it would be easy, so I put it in like this little space. I can't fit it.
So right now you have this if you write it out horizontally. Okay?
Yeah.
Wait, why don't you just simplify it?
Why can't you just simplify the top?
I'm getting there.
1 over cosine just.
I know Michael just wants to be done with it. He'll probably go home. Now, if I'm dividing by cosine squared, isn't that the same as multiplying by the reciprocal? Okay.
I don't even know what's going on.
What happens?
The cosine squared is canceled.
What do I do?
Hey!
Yay!
Johnny, quick, like, throw it out the pen.
Wait.
I love these problems.
Secant.
It's cosecant.
Wait, can you scroll that
No,
up?
it's secant, sorry.
Yeah, I read our pages and then I read our
I think, I don't even know what. I mean, back on the other No.
Really?
I don't even know.
I don't even think I saw it. I'm like, nah, I don't know if that's gonna work. So I just kind of gave up.
Oh my god, you can scroll that down.
I would have done almost right away, wouldn't I?
I know you did, but I'm just.
Oh well. Yeah, it's fine.
Okay, I want to see how you finish.
Can you scroll down real quick? Can I get one over?
That's on the test. I'm gonna put it in the paper.
I have a question. Do we get extra credit opportunities like this?
Sooner or later, I'll find you something.
Oh my goodness.
Let's see here. These are a lot of verifies, so at least you have your answers.
We're not trying on last time.
Pick a number 1 through 10.
7.
Evens.
No. Oh wait.
Well, it doesn't matter.
Let's just do the 2 through 36 even, okay? I don't think there's any. To be honest with you, there's maybe there's like 34 I can tell right now where you have to factor the numerator. We'll worry about back ones later. I don't even need that many of them.
36.
So it's the side that has 36 problems, not the side that has 14, 16. Okay. Throw it on a separate sheet of paper and we'll just get cranking away. They're ugly. Some of these are nasty. That one I showed you, it's awful.
Are there gonna be grades like that? That'd be a great extra credit.
Well, remember, this is only the second day you guys have done these. By tomorrow, that one should be easy.
Oh, yeah.
But is this the last thing we're doing?
We're gonna start. We'll do a couple of the equation ones where we have the solve the equation part.
Michael.
I did not do this.
Yeah, keep that one from yesterday's one.